Hi folks, we're going to take a look at page 8511F. So they're asking us to find the rate of change of this function at the point 3, 4. Okay, so I'll use the x approaching a formulation for this one here, just to do something a little different. So if we're looking for the rate of change, we're looking for the slope of the tangent. Okay, and that is equal to the limit as x approaches a, which in this case here is 3. So the limit as x approaches 3 of, here, I'll write it out, f at x minus f at 3 over x minus 3. Okay, and now let's input all our information. Okay, so f at x is just the square root of 25 minus x squared, and then subtract that f at 3. Well, in fact, here I don't have to calculate it because they've given me the y value when x is equal to 3. So I know it's just equal to 4. Okay, so it saves me a couple of seconds to calculate that. Okay, and as is often the case, we're going to have to do some algebra here to try to come up with an expression where we can actually evaluate the limit. Okay, so since we have a square root, we should be thinking about rationalizing that numerator. Okay, so I'm going to multiply the numerator by the square root of 25 minus x squared plus 4. Okay, and then of course I also need to divide. Or multiply the denominator by square root of 25 minus x squared plus 4. Okay, so now let's do the simplification here. Okay, so again, this acts as a difference of squareds, so it's just the first expression squared, so that's just 25 minus x squared minus the second expression squared, so 4 squared, so minus 16, and then here we're left with x minus 3 times this thing here, 25 minus x squared plus 4. Okay, and again, we keep going in our simplification. So here we're left with 25 minus 16, so 9 minus x squared over x minus 3 times this whole thing. Okay, and then finally, as we hope, we can do some factoring here. So I can factor this out as 3 minus x times 3 plus x. Okay, and I guess I'll be good here and actually write out everything in the bracket. Okay, and here we see that 3 minus x and x minus 3, when we divide those two, they just give us negative 1. So remember here, if I were to factor out a negative 1 from 3 minus x, I would just get negative x minus 3. So these two expressions reduce to negative 1. Okay, and so what we're left with in the end is the limit as x approaches 3 of negative 3 minus x all over the square root of 25 minus x squared plus 4. But now, when I look at this denominator, when I input x equals 3, or when I think about what this approaches as x approaches 3, this approaches 25 minus 9, so square root of 16, which is 4, plus 4, I no longer have this issue with a 0 in the denominator. Okay, so now I can start evaluating this limit, because the numerator here will approach negative 3 minus 3 as x approaches 3. Okay, so the numerator is going to approach negative 6, and the denominator, as we just saw, as x approaches 3, the denominator is just going to approach 8. And so that gives us negative 3 over 4. Okay, so just to recap here, I used my first formulation for the slope of the tangent using the limit definition, and I performed all the algebra necessary till I got to an expression for which I actually could determine what it approaches as x approaches 3. Okay, that is it.